Why can't you just use... Can you use second derivative every single time?
Yep. There are cases, I'll tell you when it's a bit more tricky to use the second derivative. But let's just use the table method here.
Because then it would just be -2.
It would be, yeah.
And what does that tell you?
We have to think about that. Let me use the table method here, right? When x equals to 375, let's just test numbers on either side. So 376 and 374. I already know at 375 the gradient function is 0. Let's test for 376 and 374. Tell me what values you get for that.
You just chuck it in the calculator?
Yep. So remember, when my x value are these values, I want to see what is the gradient function doing.
So you just chuck 374 into...
Yeah, chuck it into y dash.
-2.
Okay, cool.
Else get
-2.
Let me check.
that? Yeah.
-2 quick for it.
I just got
yeah, because that's the same as what the second derivative would be.
I just
You
got
can use
two.
either one, it doesn't
I
matter.
got 2 for...
Yeah.
But then that would be...
2 for minus...
That would be a different
I got
answer.
2 for 374.
Okay.
Yeah, same.
So
So the
remember-
second
Yeah,
derivative
same.
doesn't give you both answers.
So why'd you do -2, sir?
Which one?
For
So,
the 376.
there's two values I need you to test, right?
Yeah, but I did for 374,
Yeah.
I got 2.
Yeah, that's right. And then 376 is -2.
Oh, okay, so I missed it up. Is that right?
Yeah, the wrong way around.
Yeah.
Oh,
Yeah, sorry.
right,
Always
sorry.
something
Is that right? Okay, cool.
Yeah.
Remember, what does this
-2
what does this represent, right? Graphically, this is a positive gradient, so it's increasing, and then I've got my horizontal, which is there, and then I've got a decreasing function on the right. So that's clearly my local maximum. That's how you prove it. That's how you classify it. That's right. Yeah, Jesse.
If you use the second derivative,
Yeah.
you won't get both answers.
Okay, let me show you. For f double dash x, we don't need to do it, but I'll show you. Y double dash equals really interesting, isn't it? What does the second derivative tell me?
It tells
It's
us
cavity.
y minus y minus 2. It tells you what to do.
I want you to think before you speak, Callum. Alright, it's good that you have thoughts, but I want you to think before you speak. And Dylan, what did you say?
The concavity column.
Yes, thank you.
Oh, I did that this morning.
When you look at this graph, it's concavity. What's its concavity? Its concavity is concave down. And we represent that with a negative second derivative.
Guys, I'm not done.
So, in this case, usually you have to test what's happening at your point. But in this case, you know it's always concave down. If your second derivative is just a constant, just a negative number, it doesn't matter where along the curve you are, it is always concave down. So, if my whole function is concave down and I found a stationary point, what does that mean for that stationary point?
It's the maximum.
It is, because my function is always concave down, it's always a sad face. And I found a stationary point where the gradient is 0. Okay, therefore, it is a maximum.
Is it you can work that out by
So is it
proven by the table though?
It is proven by both. These are two separate methods. One,
Yeah.
What-
And
what
so,
is that?
and does
Hold
the
on.
table, does the
Jesse,
table
you don't-
prove it
You don't
by
need that
saying...
second one when you have the second
second
one.
derivative-
alright, so wait, answer the question.
Does the table prove it by saying it's positive until 0 and then it goes negative?
Yeah, so here, right, these are my x values. So imagine this is your graph going along.
Yeah.
And this y dash, that's your gradient function, which is telling me what's the gradient at that
So
point.
it's positive.
So the
then it
gradient
goes
is
0.
increasing, and then it's 0, and then it's decreasing. That has to be maximum.
Yeah.
Whereas the second derivative, you don't test around it. You actually usually test at that point. What's the concavity at this point here?
Yeah.
But in this case, there's no x value for you to substitute in. What does that mean?
It's always
Well,
concave down.
Yeah, it means no matter what x value you have, it is always concave down. The concavity, no matter where along the graph I am here, it's always concave down. So if the whole graph is concave down and I find a stationary point, what does that mean? It has to be a maximum.
And
If I found a stationary
what would that, say in the table, what
Yeah.
would those numbers be if it was a concave up?
Okay, for concave up,
That'd be opposite.
what would you expect?
It'd just be negative 2, 0, positive 2.
Yeah, you'd expect a negative value here,
Yeah.
a 0, and then a positive.
Yeah. So
Right, so that would be a local min. Question, Jesse. Keep
Yes.
going with this one if you're finished.
What is the positive 2 mean? Is it just
That's actually the gradient at that point.
and then the -2 is the gradient function?
Yeah.
No, the concave.
So this is the gradient function,
Yeah.
and when you substitute a
What,
value into the
right.
gradient function, you get the gradient
Which
at that
one?
point. Remember here, right? What's the gradient? It's
Third one.
0.
Well,
0,
for
right?
CD.
And so at any
No,
point,
you don't get
if you substitute x
No.
into your gradient function, you will get the gradient at that point.
Oh.
Maximum.
Keep going with C if you don't have to.
How do you do it?
With the second derivative,
Yes.
just because it's minus 2.
Yep.
Okay, down.
Yep.
How do you know that x equals 375 is the station?
No, you've proven that here.
That is.
Yeah. So the point for, I should say here for stat points, always communicate back
Okay,
to
so
it.
that
I think
is
that's used
proven,
station.
and then using this table.
No, I can just change for you.
Yeah. So once you've done this, that's fine. But I said you can't stop there. You either have to do this method or you have to do this method. Either one is fine. Yep. Does that make sense?
Yeah, that's
Cool.
I'm lazy, so I'll do the double dash.
Good.
The first time
There's certain context where you want to do. You want to be able to do
Yeah, I might
both.
just do the table.
So,
Table's pretty easy.
all right. So we got up to there. What's the maximum profit? That was the whole point of this question, right?
I thought we kind of like proved that in that second.
We did. We proved that when I sell 375 items, that's when I will have the maximum. But remember, Y is representing
Oh, the profit.
the profit.
It's
So
different.
what is my profit?
So we have to find one.
Well, have a think about this, and this is where you need to piece things together, right? Think about what each variable represents.
Oh.
X represents what?
I solve.
What does
I
Y
don't know.
represent?
Profit. Times them
So,
together.
when I'm looking at this, this is just a mathematical expression. I want to find.
Quadratic?
I want to find. What am I actually trying to find? I want to find Y.
By substituting in
Yes, when X is equal to 375,
Oh.
that's when I get my maximum profit.
So type it in.
Yeah.
For max profit, I should let X equal to.
375.
Good. That's it, Jesse. 375.
Oh, it's a lot of monies.
Is it?
Yeah.
It's like close
Is
to
it near
140,000. 140,000.
140,000.
141,000.
Oh, so close. I don't know that.
So you just substitute it in. And what is the digits?
141,825.
25. That is my maximum
Why'd
profit.
you put brackets in there?
Just so you.
No, I'm just tricking you because you told
think
me.
you're funny,
brackets,
Jesse?
Yeah.
Yeah, he's pretty
You
funny.
told me what brackets.
So in that case, Yellow, and can you see how we've kind of married together this idea of calculus and an everyday situation, put them together
Maths.
and have used these terms, max and min, or we only use max in this case, but we've used this idea of a maximum and applied it to a situation.
Yes.
That is, a very conceptual thing that you need to do. Do you want to get another one?
Yeah.